record for those in the back. Okay, this week is week 1. We're doing trig. On Tuesday, we did 33, and today we're doing 34. Next week, you're doing 35 and 36. It's okay, Gallie. So next week, we're doing 35 and 36. One note here, next week, Thursday, I am going to be out. I can't be with you next to Thursday. So you'll still come here for attendance, but then we'll have asynchronous learning. So there'll be a video. We've done this one time before. There'll be a video and you can watch the video. Miss Yama will be here if you have any questions. You're welcome to ask her then. But then you'll have like asynchronous time to learn. So just wanted to give you a heads up on that. And then in week 5, you are going to take the CASP test. This is the California State Test. You've probably done it in the past, like in elementary school and middle school, but the only high school California test is in 11th grade. So super important test, and we'll talk a little bit about why. But we're going to spend 2 weeks preparing. We're going to remind ourselves of our Algebra 1 and our geometry and our Algebra 2 and our pre-calculus, just so that you can feel really confident going into the test. The test actually only goes up to Algebra 2, I think. So y'all are like, have already learned all the things. I know, Janet, so fun, so fun. But I do try to make test prep as fun as possible. So hopefully we'll find some games in here. We'll learn a little bit about the platform. It hopefully won't be too stressful. So weeks 3 and 4, that'll be prep. And then week 5 will be the test. And after that, we'll probably just do PT and then we'll roll out into our summer. Can you believe it? Pretty awesome. Cool. Any questions about the testing situation? Nothing. Okay. Just wanted to remind you about office hours and a slight change for our office hours times. You can still come on Tuesdays and Thursdays, but Miss Yama is going to dedicate her Wednesday office hours to y'all, so you guys can come opposite of your VAPA class. Actually, you know what I'm realizing? Ms. Yama, y'all have college readiness, huh? On Wednesdays, you're gonna have college readiness in VAPA. Someone confirm. Yeah, starting next week. Okay, so we'll figure out when your office hours are, because they're not gonna be at this time. So forget it. Don't even look at that slide. It's over. So next week you have 4 classes on Wednesdays starting next week. So we will not have office hours then. So you can keep coming to Tuesdays and Thursdays. That's good information. Good for us to remember. Okay, never mind. Forget that slide. Okay, awesome. That's the end of our announcements today. Any questions about announcements, about quizzes, about anything? Nothing. I don't know why I said the word quizzes. I don't mean quizzes. I mean the CASP test. Okay. Y'all, I have drunk coffee, but it is not working. So we're like trying to get the coffee into my brain right now. That's the step. But is anybody else in that step? Yes, no, maybe so. All right, friends. We're going to jump into our notes. Let me know, how are we on timing? Do we need some time? Are you ready to go right now? You have paper and pencil. You got the notes pulled up if you're ready for that. If you're doing that, I'm going to go ahead and flip over to my other share here. If you need that minute, take it. As I switch screens here. Y'all, I got, because we have 20 more seconds till that 1 minute. Oh, take your 1 minute, the 12 of you. There's a lot of us who need 1 minute today. I got my Lady Gaga sleeves on today. I don't know why, but every time I wear this shirt, my morning has been okay. Thank you, Gallie. But this is how my morning is going. I'm wearing my Lady Gaga shirt. You see how they have like little puffs on them? Yeah. Makes me feel like Lady Gaga when I teach. So I always wear this shirt. Every time I wear this shirt when I'm teaching, I'm like dancing in my head. It's like a whole thing. So that's how my morning is going. I know. Lady Gaga is really cool. I don't know if you're talking about me being cool. I'm not cool, but Lady Gaga is cool. Yeah. All right. All right. It's been a minute. Your shirt should make you feel awesome. I agree. Wear clothes that make you feel awesome. Like I feel like Lady Gaga. I wear this shirt sometimes with like high-waisted pants, and I'm like, heck yeah, I feel awesome. So that's where I'm at. All right. Thanks for that joy this morning. As I should. Yes. All right, let's do this. So we have notes 34. Today we are learning about trig identities. So today we are moving away from triangle trig, and we're going to be thinking more about identities. Identities are equations. That's it. They're ideas that are always true. Ideas that are always true. Is there someone, you do not need to write this in green, or you do not need to write this down. Is there someone who could come off mute and read it for us though, so that I don't have to read that whole paragraph? Someone read it for us. Go, Diana, you got it.
In mathematics, an identity is an equation that is always true. These can be trivially
Mhm.
true, like x equal x, or usefully true, such as the Pythagorean theorem a squared plus b squared equals c squared for right triangles. There are loads of
True.
trigonometric identities, but the next two lessons include the ones you're most likely to see and use.
Amazing. Thank you, Diana. And you killed those hard words. Trivially, that's like a tongue twister. And trigonometric. I always try to think of trigonometry, trigonometric. But those are perfectly said. Thank you. All right. So these identities, things that are always true. Things that are always true. Like obviously x equals x, or like 2 equals 2. That's an identity, right? But that's not interesting. It's not helpful, right? Some of them are more helpful, like Pythagorean theorem. So we're going to learn 4 helpful reciprocal identities today. The first one is that secant x, right? So if you haven't been writing down yet, these are things you should write down. Secant x is 1 over, does anyone remember what's the opposite of secant? Remember when we were doing like x over, yeah, cosine, cosine. Thanks, Diana. It's cosine x. Be careful, Walter. It feels like it should be sine because of the s, but the s's don't actually match up, right? So secant goes with cosine. Yeah, for sure. It's kind of annoying. I honestly just remember that it is annoying. And that's how I remember that secant goes with cosine. Okay, so then cosecant, right? Cosecant goes with what? Cosecant is 1 over sine. Yeah, Jimmy. 1 over sine x. These are our reciprocal identities, right? Secant x and cosecant x. Then we have tangent, right? And in order to explain tangent, let me go on a tangent with you. Oh, well, that was a joke. Tangent is sine x over cosine x. So tangent is sine x over cosine x. Here's the tangent that you don't need to write down. So sine x is y over r, remember? And then cosine x is x over r, right? Does anyone remember, can you walk us through, how do I divide fractions? I have a fraction divided by a fraction. How do I do it? Multiply. Multiply times what? I take the first one, multiply times, yeah, times the denominator, times the flipped version, right? So it's like some people learn like keep, change, change. I learned copy dot flip. You copy the first fraction, you put a dot, and then you flip the second fraction. So it would be r over x. The mathematical term is multiply by the reciprocal, right? By the reciprocal of the second one. What is that going to do with the r's here? What's that going to do with the r? What's r divided by r? Or 10 divided by 10, 18 divided by 18. They cancel the divide by 1, right? So then we'd be left with y over x. Do y'all remember that y over x is the same as tangent? Wild. Math is so cool. I know. It's awesome. So tangent is equal to sine over cosine, right? So that's what we're memorizing today. The blue part, memorization, right? The purple part is the why, or the showing how. All right, so cotangent is the opposite of tangent, which means that the reciprocal version is 1 over tangent x. But what it really means is that it's the reciprocal of tangent. It would be cosine over sine. Cosine over sine. So I try not to do this too often, but memorization is what's happening here. The things that are in yellow here, these are the things that we need to memorize. Right? You can memorize this one in the middle if you want, but if you remember, cotangent is cosine over sine. That'd be helpful. All right, what we're going to do today is we are going to be given some things that they want us to simplify. So you can imagine the directions here say simplify. And the basic strategy that we're going to use is we're just going to convert everything that we can to sine or cosine, right? So if we see secant, we're going to turn it into this fraction. If we see cosecant, we're going to turn it into that fraction. If we see tangent, we're going to turn it into this fraction. If we see cotangent, we're going to turn it into this fraction, right? The goal being, if I can get everything in sine and cosine, then hopefully some of my sines and cosines will cancel out, right? And we can make it more simple. So let's check out this first one here. It says tangent x times cosine x. What can tangent be turned into? What fraction can I turn tangent into? Based on my
Sine x over cos x.
Yes, it's sine over cosine. So regular tangent is sine over cosine. Sine x over cosine x. All right, so regular tangent. Yeah, I got a good correction in the chat. Sine over cosine. And then it's times cosine x. I'm just bringing this cosine x straight down. Remember that it's like over 1, right? So now I have 2 fractions. What can I simplify now that it is written like this? Cosine, yeah. Cosine divided by cosine is just 1. So I have sine x over times 1 over 1. No, it doesn't matter. So now I just have sine x as my answer. Yeah, Emma, it is over 1, but we actually don't have to write the over 1, right? Since we're simplifying, our goal is to write as little as possible, really. And so we just have sine x. It's perfect. So cosine and cosine cancel, we get sine x here. So what we can essentially say is that tangent x times cosine x is mathematically the same as sine x. Pretty cool, huh? So what we're going to do today is basically just change everything to sine and cosine and see what cancels. Can someone help me with B? What can I change cosecant x into? What do I change cosecant x into? 1 over sine for sure. 1 over sine x. What can I change tangent x into? Sine over cosine. And for the record, like, yeah, they all have x's after them. If you want to not write the x's as you're doing the work, that's okay. Just to make sure that you do have the x in your answer. So we have 1 times sine over sine times cosine. Does anything cancel here? Yep, sine cancels, and I get 1 over cosine x. I'm thinking, let me go back to my reciprocals. How can I simplify 1 over cosine x? Which of these is equal to 1 over cosine x? Yeah, secant x. Secant x. Secant x. Just like that. So secant x becomes my answer. How are we feeling about these ones so far? Tell me this to 5. How are you feeling? 0, like what the heck are we doing this? To 5, like, okay, obviously I'm just changing these things. I could do this. Cool. We're looking at some 3s, some 4s, some 5s. Some people not responding in the chat. All right, cool. Thank you. All right, looking like mostly 4s, so feeling good. All right, let's look at C then. C, we see something like slightly different with this squared. All this means is sine x times sine x. Like it's like, it could also be written like sine x squared, like that, right? So we have 2 of them. For my simplification, I'm going to write sine x times sine x, just so I remember that there are, in fact, 2 of them. So I'm converting sine squared x into sine x. What can I convert cotangent x into? Looking at your notes, what can I turn cotangent x into? Cosine over sine, yes. Cosine x over sine x. Remember, these are still over 1. What, if anything, can be canceled here? Yeah, one of the signs. All right, one of the signs can be canceled. So sine x divides to 1. So I would have sine x times cosine x over 1. So I'd have sine x times cosine x. There's nothing I can do about that. So that is my answer. So in the previous ones, it simplified all the way down to one thing, right? In this case, it simplifies into 2 things being multiplied. So there are some situations, just like if you get to like 2x squared plus 2, you can't do any, well, plus 3, can't do anything about that at that point. All right. If you're someone who has a quiet area nearby you and you'd like to come off mute, feel free to put your raise hand button up. Feel free to use that raise hand button. We'd love to have a couple people come off mute as we work through these next few examples. Be brave, you can do it. Would love to see those raised hands. All right. Find that chat box. All right. What can we turn tangent into? What can we turn tangent into? Kayla, what do you got?
Well, from what I see, you can do sine over cosine.
Yeah, perfect. Thanks, Kayla. Do you want to keep going?
I'm sure. Give me a minute.
Yeah, no problem.
Then you have cosine over sine in the bottom.
Cool.
Then, like in the other one, we said you flip the denominator. It'd be sine over cosine times sine over cosine.
times sine. So you're taking this fraction and you're finding the reciprocal, right? So you're multiplying times the reciprocal. Amazing. Great job, Kayla. Any more thoughts? This is kind of tricky. We haven't really done this before.
From there, I'm not so sure. I want to say it's like sine, 2 sine or sine squared, but I'm not entirely sure from there.
Yeah, you can totally do that. You could say, okay, sine squared x over cosine squared x. Just like that. I love that. Great job. Okay, there is one more thing we can do. What is sine over cosine? What is sine over cosine? Tangent, right? So sine squared over cosine squared is just tangent squared x. Yeah, exactly. Tangent squared x. Whoa. Mind blown, right? Mind blown. Here, there's actually another way you could get there. So Kayla got us there by doing sine squared over cosine squared. You could also just say, okay, sine over cosine is tangent, and sine over cosine is tangent. So tangent times tangent is tangent squared. You could also go that way. This is one of the beautiful pieces of mathematics where like there are many ways to get there, right? Many ways to get there. You could also say, like if you had way back at the beginning, if you said like, okay, this is tangent over 1 over tangent, then you'd say, okay, I have tangent times the reciprocal of this, which is tangent over 1. And then you'd be like, tangent squared x. Another way to do it, right? There are lots of ways to do that. Awesome. Amazing. Snaps for Kayla. Kayla, appreciate you on that one. Awesome. All right. Let's go ahead. Let's take a moment. Take a moment. Try this one on your paper. See if you can get to an answer for tan x over sine x. Tan x over sine x. And then I'd love to see a raised hand if you want to try just to take the first steps. Emma, go for it. Take the first steps for us.
Okay, so what I did first is I changed tangent x into sine x over cosine x.
All right.
And then I just went straight to keep change flip. So then I just put the time sign. And to flip sine, you would use 1 over cosine, but because we're doing keep change flip, I just flipped them already to cosine x, or yeah, cosine x over 1.
Cosine x over 1. Wait, Emma, go back. This is, this is like sine x over 1, right?
Uh-huh.
So when I flip it, what will it be?
What?
So since this is sine x over 1, when I do the reciprocal in order to multiply it,
Oh, so that'll be cosine x.
Yeah, exactly. Great job. Right, so the green part is turning into, when you do the reciprocal, you have 1 over sine x. You want to keep going, Em?
The signs would cancel out and it would be 1 over cosine x.
1 over cosine x. Yes, absolutely. I agree. I would argue that we can take it one step further. How could we simplify it?
Cosine can which one's cosine? Cosine. Oh, there's nothing in the notes about cosine. Oh wait. Can we change it to secant x?
Yes, we can change it to secant x. Great job. Thank you for checking your notes. We can change it to secant x. 1 over cosine is secant. Amazing. Dr. Emma. Great job, Em. Thanks for helping us on that one. Love it. Woo. Alejandra. Why did we flip the sine x and 1? Oh, yeah. Okay. So Emma did this in her head, I think. But basically, we would have tangent is sine over cosine. And sine is sine over 1. And because we're dividing, how we divide fractions is we actually multiply times the reciprocal. So we keep the same one. So sine over cosine, that went here. And then sine over 1, we needed to flip this fraction in order to get 1 over sine. We did not do that for D. Well, we did do that for D. We had sine over cosine. That's this yellow one here. And then we took the green one and we flipped it into sine over cosine. It was cosine over sine. We changed it to sine over cosine. Like that. Perfect. Thanks for asking that question, Ollie. Great job. Yeah, great job, Emma. Nice. Emma, I'm going to lower your hand just for now. You feel free to raise it again. All right, we've got F. Let's jump into F. Whew. Okay, we got 2 squared ones. Right? We don't need to be scared though. Just because it's squared doesn't mean we need to be scared. Oh man, I am funny when I'm wearing my Lady Gaga shirt. All right. Anybody want, let's try it. Take 30 seconds, see if you can wrap your brain around it. And then when you feel comfortable, even if you don't have a final answer, if you feel comfortable with like a step that we could take, go ahead and raise your hand. If you don't have a quiet space, you're also welcome to private message me what you think the first step could be. Yeah, Diana, you got it?
So what I put was cosine x over sine x 2 times.
Cosine x over sine x. Can you talk why cosine over sine?
Because cos is equals, well, I went to look up at our notes and I saw that cos equals cosine x over sine x.
Yes.
And then it
And
was squared. So I figured we should put it 2 times. And also for secant, it's 1 over cosine x times 1 over cosine x.
Yes, absolutely. Just so you feel comfortable, Diana, that cot, like C-O-T, that's cotangent. That's how we say it.
Okay.
Cotangent. All right, cool. Now what?
And then you can start canceling. The both cosines at the top can cancel because there's 2 at the bottom. And then it's 1, hold on. So ones. And then it'll be 1. It's gonna be 1 sine x times 1 sine x.
1 sine x times 1 sine x. I agree, but they're in the denominator. So I'm going to leave the sine x's in the denominator. My pencil's dying. Here we go. So we have sine x times sine x in the denominator. Okay, we're not quite done. Diana, do you have any idea how to move forward, or do you want to toss it to someone else?
Pass it to someone else.
Okay. We're not quite done. What can we do here, friends? Yeah, Gally.
So from there, you get the, obviously you can combine the sine x's, but you know that since they're separate already, you can like separate it into two, like if you already had before. And then you know that 1 over sine x is the inverse one of it. So I don't know what it's called, but
Cosecant.
yeah, there you go, the cosecant.
No. Yeah, there you go.
So then you get cosecant 2x.
Yeah, so we have two of them, right? They're turning into each of these, and that would be cosecant squared x. Thank you, Gally. Good idea. Thanks, Diana. Diana and Gally, snaps to both of you. Thanks for helping us out on that one. Appreciate that. There was one argument you in the chat that you could up here where it says cotangent squared x, you could put 1 over tangent x twice. That is true. It's just less helpful to us than cosine over sine, right? Remember our golden rule, our basic strategy is to convert everything to sine and cosine if possible. So since cotangent is cosine over sine, that makes our problem easier to solve or easier to simplify, right? So that's the only reason to do it that way, for sure. I saw you corrected yourself. That's awesome. I love this. I'm thinking another way that you could have jumped here is you could have said, okay, these make 1s over here and these make sine squared x. So then sine squared x immediately goes to cosecant squared x. Cosecant. Let me go ahead. I'm going to put in the chat like the full names. So you have secant, spelled like is how we say it, secant. We have cosecant. We abbreviate to CSC, and then we have cotangent, which we abbreviate to COT. Amazing. Awesome. All right, we have our last example here. This is our most challenging one of the day. Most challenging one of the day. Go ahead and take a moment. If you feel comfortable giving us a first step, go ahead and raise your hand. Emma's already there. Emma, I'm going to give everybody a moment. Unless you have a question. If you have a question, come off mute. But if you are ready to help us out, go ahead and raise that hand. All right, Emma, talk to us about your first step or two.
Okay, so I started with I just left cosine how it is because we're trying to change them all to cosine or sine. So then I went straight over to tangent and I made it sine x over cosine x. And
Okay.
then 1 over cosecant, I changed that into sine x.
All right. You're welcome to keep going if you feel like it.
Okay, so then I know that cosine x is basically cosine over 1. So then the two cosines would cancel out, and it would be sine over 1. But there's also another sign in the numerator, so it'd be sine squared x over 1.
Sine squared x over 1.
But you
All
don't
right.
have to write the over. Yeah.
Oh, okay. I don't need to write the over 1. Galilee, do you agree with this process? Did you do it a different way? What are you thinking?
Well, I didn't write down anything, but yeah, that looks about right.
Okay, thanks, Galilee. Devin, can you say more about what you just private messaged me?
I think it's 2, like the 2 goes in the front, so it becomes 2 sine of x, because you're adding the 2 sines, you're not multiplying them.
So Emma's making the argument that there's 2 of them, so we should put sine squared x. And Devin's making the argument that we should put 2 sine x because we're adding them together. 2 sine x. So we have sine x plus sine x. Emma's agreeing with you now. She's changing her answer. Galilee says he big brained it. Didn't even see that it was a plus sign. Yeah, it's a plus sign, right? So I would agree as well with Devin that it is not squared, right? We're not multiplying sine x times sine x, right? But we actually have sine x plus sine x, which literally means we have 2 of them, right? We have 2 of them. So that's going to give us 2 sine x as our answer. 2 sine x. Snaps for Emma, snaps for Galilee, snaps for Devin. Thanks for setting us straight, Devin. Thanks for getting us started, Emma and Galilee. Appreciate you. All right. Now that we've seen a whole bunch of examples, y'all, look how many examples I did all in the time. All in the time. How are you feeling about this topic now that we have progressed? Nice. Looks like we're feeling pretty good. Some of us still feeling like, oh, little Awesome. Okay, as you're still voting there, that's great. For your trig identities today, for your assignment, if I let this load, it really does not like moving. Dun, 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 dun. For your assignment today, you're already done with the notes, so you got that knocked out. For part 1, you're gonna fill in these blanks. This is just like a reminder for like a memorization trick is to write things down again. So you're gonna fill in that section. And then you're choosing 8 out of 1 through 10, right? So you're doing eight problems like this, like the ones that we just did. You should see your answers in the blue box. You're gonna put your picture here. And then you are choosing, there are 4 questions like yesterday. I felt like yesterday we were like a little, like we just need more practice, right? Not that you didn't understand, but we just need a little bit more practice. So there are 4 problems like yesterday, right? This is yesterday's note. You're just gonna do 3 more problems like that so you can get some more practice. You'll notice the answers are in degrees because the question is asking from 0 degrees. Theta is in between 0 degrees and 360 degrees. Okay, so your answer is in degrees. That is the end of your official assignment. If you are interested, I did attach some ACT practice here. I want us to practice, particularly for this class, I want us to practice the last 10 questions. So you'll notice that the questions here are from 50 to 54. Yeah, 50 to 54. This is like the back end of the test. This is where we get those like big points. If we are already at like high levels, which I know we are, this is where we get the big points. So I want us to focus on those. If you feel like doing the ACT practice, it is extra credit. You do not need to do it. I'm not requiring it. But I am requiring 8 problems from our new identities and 3 problems from yesterday's review. Okay, so that is our assignment for today. If you have any questions, feel free to stick around. I know most of you have Spanish now or in a little bit, so you are free to head out. Great job today. Shout out to everyone who came off mute. I will send you some merits. Appreciate you and everyone who helped in the chat. Thanks, friends. Adios, amigos. Thank you. Thank you. Have a great day. Come back for office hours. If you have any questions, you can come today. Don't come on Wednesdays. That's not going to work out for us, but we'll make it happen. Bye, friends. Have a great day. Bye. Bye-bye. Adios, friends. Have a great day. Bye.